Hello and welcome to Mitra's Alchemy. Today we are going to solve a practice problem for the JEE Advanced. So let's begin. Let fx equals to half a naught plus summations of cos and sine terms. Then I have to integrate fx cos kx from minus pi to pi, and these are the options. So now I would ask you to pause this video, try this question once by yourself, and then come back to look at the solution. Let's begin with the solution. Let me put this question aside so that I can get more space for my solution. I have taken capital Fx equal to small fx times cos kx, which is the exact integrand. When I expand the terms, it looks like this, but every term is multiplied with cos kx. This looks really big, so we look at the terms one by one. Let's begin with the last term first. Okay, and this term, when I integrate, should give me 0. How is that? Because this is an odd function. And what makes it an odd function? This sin x term. Sin x itself is an odd function, thereby making the entire function an odd function. And the integration of any odd function from minus pi to pi is always 0. Hence, I get rid of the last term. Next, we see the first term. Now what happens to it? I take the half a naught directly outside because it's a constant anyway, so I just have to integrate cos kx dx from minus pi to pi. Now what I do? I can make the integral limits from 0 to pi by multiplying a 2 outside. How do I do that? Because cos kx is an even function. Okay, for any even function, we can take the limits and make it half. That is, from minus pi to pi can be converted only to 0 to pi, and the entire integration can be made double, as we can see here, which will give me the same result. But still, if I integrate and plug in the values, it will still give me 0. Hence, I also got rid of the first term. Now we only have one single term left, which is the second one. Let's see what happens to it. Now if we expand this term, it looks really big. a1 cos x, cos kx, a2 cos 2x, cos kx, and so on and so forth, right? Now even though this looks big, this can be shortened up. How do I do that? I take the general term, which kind of looks like this, which is almost similar to the last term, as you can see. So an cos nx cos kx dx. Now why do I take the general term? So that I will integrate this general term and apply the same concept to each and every term. Let's see what happens. I take an outside because an is a constant anyway. So I have cos nx cos kx. What do I do with it? I multiply and divide by 2 so that this entire term can become an addition of 2 terms. What did I do? I have 2 cos a cos b getting converted to cos a plus b cos a minus b. Okay, so this I integrate separately to finally get an by 2 times sine of n plus k by x by n plus k plus sine n minus kx by n minus k. Fine. So now I plug in the limits and it again goes to 0. But the question is, does it always become 0? No, it only becomes 0 when n is not equal to k. Now what happens when n is equal to k? Let's see. When n is equal to k, we have this entire general term written with n equal to k. Okay, I have ak by 2 cos of 2kx plus cos 0x dx. Now we can see that these terms can be split up, cos 2kx and cos 0. We all know that cos 0 is 1. And what happens to this term? This term will eventually go to 0, as we have seen in the previous integrations, right? Now we only have to bother about the cos 0 part, which is just simply dx, 1 times dx. Okay, so I have ak by 2 integration of minus pi to pi dx, which finally gives me the simple integration of 2 pi. And finally I multiply the terms and I get pi ak, which is my option C. And thus we conclude our video with the answer being option C. Hope you liked the video. Leave us a like and subscribe.